Hello, class, and welcome to Chapter 19 on air pollution. I'm going to go over the next couple chapters a little bit more quickly to give you guys time to read in your textbook. Chapter 19 covers air pollution. I'm going to kind of pass over the introduction and kind of get right into the material here. So our atmosphere around the Earth is a resource, and you can see that most of the atmosphere is made up of nitrogen. And different ecosystem services that our atmosphere does is it blocks UV radiation, moderates climate, and redistributes water in the water cycle. Air pollution is whenever we add chemicals to the atmosphere by natural or human activities in high enough concentrations that can be harmful. We can have primary and secondary air pollutants. Primary means they are emitted directly into the atmosphere, and a secondary air pollutant is actually found in the atmosphere when the primary air pollutant reacts with substances normally found. So here we have major air pollutants, whether that's dust, lead, sulfuric acid, methane, benzene, and chlorine. And you can see there if it's a primary or a secondary air pollutant. So again, primary air pollutants are directly released into the atmosphere, and secondary air pollutants will be what is released when a primary air pollutant actually reacts with something in the atmosphere. Here are the major classes of air pollutants that we'll go over now, whether it's particle material through ozone, and we'll go through each one of those individually. So a particulate material would be thousands of different solid or liquid particles, whether that's soil, soot, lead, sulfuric acids. And these can be dangerous because they could be toxic or carcinogenic, and then are different gases produced by chemical interactions in the atmosphere. They can cause either difficulty breathing in the greenhouse gases or actually cause acid precipitation. Carbon oxides are the green hard gases, and hydrocarbons, some can be related to photochemical smog or greenhouse gases. Ozone then, so the tropospheric ozone is the man-made pollutant in the lower atmosphere. It's a component of photochemical smog, and the stratospheric ozone is the essential component that actually screens out UV radiation, and man-made pollutants like CFCs can destroy it. So this is a look at just ozone damage to grape leaves. So here we see all the air pollutants, and the majority is made up of carbon monoxide. Sources of air pollution, we see the main source of air pollution is transportation, with second being fuel combustion, except in vehicles. Intentional forest fires can also contribute to air pollution as well. Urban air pollution, this is the industrial smog, which is made of sulfur oxides and in the afternoon. And this is a look at something we're familiar with, Los Angeles, a brownish orange haze formed by chemical reactions involving sunlight, nitrogen oxide, and hydrocarbons. So here we have a look at how a photochemical smog is formed, due to many sources of pollutants, reactions. There's different efforts to reduce the ozone in Southern California, reducing volatile organic compounds. Temperature inversions will increase with altitude where pollution is trapped as well. California consolidated efforts to improve air quality in 1977, and improvements were due to a few major regulations. So here are the sources of smog in Los Angeles, mainly due to transportation vehicles, some industries as well. The effects of air pollution, it can irritate eyes, cause inflammation of your respiratory tract, but eventually it can develop into chronic problems like emphysema or chronic bronchitis. So here we have health effects of pollutants, looking at the source, and then the actual effects, which is kind of scary to look through. There's a greater health threat to children than adults because children breathe more often, and air pollution can restrict the lung development. So children who actually live in these high ozone areas are more likely to develop asthma. We can control air pollution via smokestacks, where electrode imparts negative charges on the air pollutants, and then these negatively charged pollutants are then positively attracted to the walls, and then they'll fall into a collector, and only clean air goes out. That's what a smokestack does. Smokestacks with scrubbers is when particulate material can also be controlled by proper excavating or cleaning techniques, And in cars, this is what a catalytic converter is. So in China, we see emissions not controlled. So just for example, this is an example of emissions not controlled, heavily polluted. And in North Carolina, we see emissions that are controlled with scrubbers. So only the steam is expelled. In controlling air pollution, we can have a phase one vapor recovery system for gasoline, where the vapor comes off of the gasoline in an underground tank. There was a Clean Air Act imposed in 1955 and then updates in 1990, which authorizes the EPA to set limits on the amount of specific air pollutants. And it focuses on these 6 major pollutants. And the act has led to decreases in air pollutants, especially since 1970. Urban air quality. So this is just interesting looking at the different cities in the States, seeing, extreme air quality and how it decreased in about 14 years by 2013. Ozone depletion. So like we talked about, when the ozone gets depleted, we lose that protectiveness of the earth from the UV rays. And we can see that ozone thinning or a hole was first identified in 19 and November because it's caused by human producing bromine and chlorine containing chemicals like CFCs. The hole requires 2 conditions. Sunlight just returned to the polar region in the circumpolar vortex, which is a mass of cold air, and the polar stratospheric clouds form, enabling chemical reactions that cause that chlorine and bromine to destroy ozone during those months. So effects of the ozone layer becoming depleted, there's just higher levels of UV radiation, which can cause eye cataracts, skin cancer, a weakened immunity. It can disrupt ecosystems and may damage crops and forests. Recovery of the ozone layer, we can reduce CFCs, started using HCFCs, and phase out of all ozone-destroying chemicals. Satellite pictures in 2000 actually indicated the ozone layer was recovering, but full recovery will not occur until 2050. Acid deposition is due to sulfur dioxide and nitrogen dioxide reacting with water to create this acid rain, which can be a very acidic rain on the pH scale. So anything less than 7 is very acidic. And this goes through how acid deposition or acid rain develops. It's basically taking sulfur and nitrogen oxide, combining with secondary air pollutants in the clouds, and then combining with water to produce this acid rain and surface runoff. Effects of acid rain or acid deposition, it can decline the aquatic animal populations. It's creating thin-shelled eggs, preventing bird reproduction, and allowing for a forest decline. For example, look at that black forest in Germany. So we can see here how acid rain can cause forest decline because the acid rain will be taken up by the trees in the soil, and that leads to the death of the tree. Acid deposition is cross-boundary issue. So pollution is one place, but problem is another. So trying to manage that. Air pollution around the world. So here are the 5 worst cities, many in China, India, and then there's Santiago, Chile, Mexico City, and Mongolia. And that's mainly due to there's just poor air quality, and a lot of those developing countries have older cars. So here we have India and China, examples of those air pollutions. Long distance transport of air pollution. So, air pollution can be transported then, across the world. It can leapfrog in between continents, depending on airflow and so forth. So air pollutants can be transported. Indoor air pollution, pollutants can actually be 5 to 10, 100 times greater than actually outdoor. So indoor air pollution can be caused from radon, cigarette smoke, carbon monoxide, pesticides, lead, cleaning solvents, ozone, and asbestos. So here we see all instances of indoor air pollution. So actually, the most dangerous place to be might actually be inside your home. Tobacco and radon, so cigarette smoke, radon, and that leads us to the end of chapter 19. So a little bit quicker getting through that, but I want you guys to see if we can get more people listening and watching these videos. So I'll keep it short and sweet and look for chapter 20 posted soon.